Circles, chords, and tangents. Let's go through some of the properties of circles, chords, and tangents, as well as some of the angle properties involving circles, chords, and tangents. We are going to begin by the length of an arc. How do we get the length of an arc? We have the length of the arc given there. It is indicated by that arrow marked in red. So how do you get the length of that arc marked in red? It is given by this formula. The angle at the center, which is bordered by the 2 radii, divided by 360, multiplied by 2 pi radian. Let's look at the example. Find the length of an arc subtended by an angle of 250 degrees at the center of the circle of radius 14 centimeters. Solution: to get the length of the arc, we've said we use this formula, theta, which is the angle at the center, divided by 360 times 2 pi radian. Just substitute. The angle is 250 divided by 360 multiplied by 2 pi times radian. That will give 61.11 centimeters. That is how you get the length of an arc of a circle. Number 2, perpendicular bisector of a chord. We are going to begin by definitions of these terms. What is a chord of a circle? What is a diameter? And what is a radius? The chord of a circle. A chord of a circle is a line segment which joins 2 points of a circle. The diameter is a chord which passes through the center of the circle, and the radius is the distance from the center of the circle to the circumference. Let's look at the perpendicular bisector of a chord. A perpendicular drawn from the center of the circle to a chord bisects the chord. There are 2 diagrams that I've drawn to illustrate this. That if you have a perpendicular drawn from the center of the circle is O, as you can see here. This is the center of the circle, O. If you draw a perpendicular from the center of the circle, it will bisect this chord. The chord here is PQ. Bisecting means it will divide chord PQ into 2 equal parts, and therefore this chord PQ, after being bisected, you'll notice that PR will be equivalent to RQ. So in the second diagram, I've indicated that. So you have the center of the circle here. So if you draw a perpendicular from the center of the circle, and where it meets the chord, it bisects the chord. Note that the perpendicular drawn from the center of the circle to the chord bisects the chord. Bisecting means dividing it into 2 equal parts. Then a straight line joining the center of the circle to the midpoint of a chord is perpendicular to the chord. That is the second diagram. So look at this line that is drawn from the center. It meets this chord DU at 90 degrees, as well as bisecting it. So this line from the center, it is perpendicular to the chord and it bisects the chord. Let's look at this example. The radius of the circle center O is 13 centimeters. Find the perpendicular distance from the chord if AB is 24 centimeters. So you have this diagram here. AB is 24 centimeters. So that means if we go by the property that this perpendicular from the center of the circle meets the chord at 90 degrees. So this line from the center of the circle to the chord, it is perpendicular, and it also bisects this chord AB. So if AB is 24 centimeters, then this will be 12, this will be 12. That is what we mean by bisecting. So once you draw that and you have from the center, the radius is given as 13, and you have this as perpendicular, you'll note that you'll form 2 right angled triangle, and therefore finding the perpendicular distance from the chord, this is the perpendicular distance, OC, this is what you're supposed to calculate. And having identified that AC is equals to CB, that is 12, 12, and you have used that property here. that perpendicular drawn from the center of the chord bisects the chord, and also it meets the chord at right angle at 90 degrees. So we will have these two right angle triangles which you can use. You can use Pythagoras theorem to get OC. So OC is equals to 13 squared minus 12 squared, get the square root of that, and this will give you 5 centimeters. Number 3, parallel chords. Any chord passing through the midpoint of all parallel chords of a circle is a diameter. Look at these chords. These chords are parallel to another. So if you have any chord that is passing through the midpoint of those parallel chords, midpoints of those parallel chords means that this chord will divide these two parallel chords into two equal parts. They are equal. So that is the diameter. So this chord here that passes through the midpoints of these two parallel chords is a diameter of the circle. Is very good. So we go to the next property, and the next property is intersecting chords. Intersecting chords of a circle. So you have two chords here, AB and CD. Those chords are intersecting at E. So this is a property involving intersecting chords. When you take DE divided by AE, let's look at the diagram, that is equivalent to EB divided by EC. Or if you cross multiply this one, you can also use this property. DE multiplied by EC is equivalent to EB multiplied by AE. So that is the property involving intersecting chords. An example, in the previous diagram, AB and CD are intersecting chords. Given that AE is equals to 4, I've indicated AE is equals to 4 there, and CE is equals to 5. CE is equals to 5. And DE is equals to 3. D is equals to 3. You're supposed to find AB. Find AB. Find AB. So this is how we do it. So using this property here, DE times EC. So DE times EC is equals to EB times AE. EB times AE. So since we don't know EB, we can let EB to be represented by X. So we just need to take DE. DE is 3. DE is 3. Then times EC. EC is 5. Is equals to EB. EB, we let that one to be X. EB is X. Yeah. So that one is X. Multiply by AE. AE is 4. Like that. So you can get X here. So this will be 15 is equals to 4x. So x therefore will be equals to 15 divided by 4, and this will give, so 15 divided by 4 will give 3 3/4. So 3 3/4, or 3.75 centimeters. So that is X, and remember X was what? Remember X was EB. That is EB. We have not answered the question. We are supposed to find AB. AB. AB, look at AB. AB is, we are going to obtain that one by taking AE, which is 4. Then plus EB. EB is 3.75. 3.75. So this will give 7.75 centimeters. That is how you're supposed to solve that. We go to the next property, equal chords. 1. Angles subtended at the center of the circle by equal chords are equal. 2. If chords are equal, they are equidistant from the center of the circle. So those are the two important points that you need to understand about equal. There is a diagram to illustrate these. The first diagram is explaining about point number 1. Angles subtended at the center of the circle by equal chords are equal. So which are the equal chords here? Equal chords are DC and AB. And those ones are subtending, like AB is subtending this angle at the center. Then chord DC, which is equal to AB. Remember that AB and DC are equal chords, and AB is subtending this angle here at the center. Then DC is subtending this angle at the center. So these two angles are equal. So this angle A is equal to that angle A. So that is what we mean by the first point. Angles subtended at the center of the circle by equal chords are equal. Let's go to the second point. If chords are equal, they are equidistant from the center of the circle. If chords are equal, in this case, AB is equal to CD. So those two chords are equal. Then they are equidistant from the center of the circle. The center of the circle is E. The center of the circle is E. So equidistant means that these distances are the same. From F to E is the same distance with E to G. That is what we mean by that. Or if chords are equal, like in this case, these two chords, AB and CD, are equal, then they are equidistant from the center of the circle. Very important property. We go to the next, secant. What is a secant? A secant is a chord that is produced outside the circle. A secant is a chord that is produced outside the circle. For example, AC is a secant, DC is a secant. So you have two secants that are intersecting outside the circle, or these chords that are intersecting outside the circle. There is a property connecting to that. The property is here. BC, if you take BC divided by EC, that is equivalent to CD divided by CA. Or if you cross multiply, you get BC multiplied by CA. So BC multiplied by CA is equivalent to CD multiplied by EC. As simple as that. Tangent and secant. What is a tangent? A tangent is a line which touches a circle at exactly one point. The first diagram is showing a tangent, a line that touches a circle at exactly one point. Then the second one is showing a secant. Property 6, tangents to a circle from external point. If two tangents are drawn to a circle from an external point, point number 1, they are equal. 2, they subtend equal angles at the center. Then 3, the line joining the center of the circle to the external point bisects the angle between the tangents. This is the diagram to illustrate that. So we have two tangents that are drawn to a circle from external points. The tangents here are AP and BP. Those two tangents are equal. So if you have two tangents that are drawn to a circle from an external point, they are equal. So that means that AP is equals to BP. The point number 2, they subtend equal angles at the center of the circle. They subtend equal angles at the center of the circle. So these two angles here, look at angle AOP, angle theta there, and angle BOP. So those angles are equal. So if this angle is, let's say, is 80 degrees, this one should also be 80 degrees. Then number 3, the line joining the center of the circle to the external point bisects the angle between the tangents. So look at this line that is drawn from the center of the circle. Look at that line. It bisects the angle between the two tangents. The angle between the two tangents is this angle APB. So if this angle, let's say 60, it is bisected into two, that is 30 and 30. That one is very important. Number 7, we have another important property, the tangent radius property. This one states that the tangent is always perpendicular to the radius at the point of contact. So we have the radius there, we have the tangent. Look at the point of the contact of the radius and the tangent, always perpendicular on 90 degrees. Number 8, tangent secant property. Tangent secant property. So here we have DC is the tangent. So this is the tangent. And then AC is the secant. So this property involving tangent and secant is given here, that when you take DC squared, the length of DC, you square that. That is equivalent to AC, you can see AC multiplied by BC. Number 9, angle subtended by the same chord at the center of the circle. And this is a very important property, and this is how it states that the angle subtended at the center of the circle by the same chord is twice the angle subtended at the circumference. So look at this chord AD. Chord AD subtends this angle at the center 2x, and also it subtends this angle x at the circumference. This is what we say, that the angle subtended by the same chord, and the same chord here is AD, it subtends this angle at the center and also subtends this angle x at the circumference. So we say the angle subtended by the same chord at the center of the circle is twice the angle subtended at the circumference. So if let's say this is 120 degrees, this angle will be 60 degrees. The same case applies to the other angle here. So look at this chord AD subtends this angle 2x at the center, and also the same chord subtends angle x at the circumference. So the angle at the center subtended by this chord AD is twice the angle subtended by the same chord at the circumference. Number 10, angle subtended by the diameter of the circle. This property states that the angle subtended by the diameter of a circle at the circumference is always right angle on 90 degrees. So the diameter here is AB. AB is the diameter. It subtends this angle C at the circumference, and also it subtends this angle D at the circumference. So angle C and angle D are 90 degrees. So any angle subtended at the circumference by the diameter is always 90 degrees or right angle. So number 11, angle in the alternate segment. So if you're given the tangent, in this case, can name this tangent as AB. So let's say this is AB, and then this one is let's say X. So this angle that is here subtended by this tangent A is the same with this angle that is here. Why? Because those two angles are in the alternate segment. So look at this angle A, it is in this segment. It is in this segment. So this angle is equal to the angle in the alternate segment. The angle in the alternate segment is this angle. So looking at this segment that you've shaded here, the alternate segment is the one that I'm pointing with the arrow. So this angle A is equivalent to this angle A, and those are angles in the alternate segment. On the other side as well, this angle B here is on this segment here. So that is in the alternate segment with this angle that is here. So angle B. So angle B and angle B, they are equal because they are in the alternate segment. They are angles in the alternate segment. So if A is 50, the other A is 50. So if this, let's say this is 50 degrees, this one should be 50 degrees. If this one is 60 degrees, then this one should be 60 degrees as well. The next property, angles subtended at the circumference by the same chord. Angles subtended at the circumference of the circle by the same chord are equal. Now look at this diagram here. The chord is AB. This is the chord. And you can see it is subtending all these angles. The angle A, let me name this one differently. So it's subtending angle X there, angle Y, angle Z, angle W, angle N. So all these angles, angle X, angle Y, angle Z, and angle W, angle N, they are all subtended by this chord AB at the circumference. So all those angles are equal. So all these angles, let's say angle X is A, this one should be 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 A, and so on. That is a property that angles subtended by the same chord at the circumference are all equal. So all those angles X, Y, Z, W, N, they are all equal. And those are some of the important properties involving circles, chords, and tangents.